Okay, great. Well, good morning, everybody. Steve Coleman, Ohio State University, standing here with Greg LaBarge, also with Ohio State University. I'll just start by asking you to tell us a little about yourself and your role in the university.
Yeah, actually, I've been with the university for 33 years. What I do currently is a field specialist in agronomic systems. What I've been working on primarily is in relationship to the issue of nutrient management and Lake Erie and some of the issues that we have in water quality up in that direction. Before starting this position back in 2011, I was a county educator up in Fulton County, so a lot of years of experience working with farmers directly on practices and implementation.
So you've got a lot of experience in terms of kind of a statewide appointment and a lot of interactions in terms of different county educators in different areas. We're interfacing with OSU researchers and trying to extend that information and educate stakeholders in the state.
Absolutely.
Okay, great. So we're standing here in Beck's London facility. It's real close to Farm Science Review. And this is a unique site because it's part of some of Ohio State's efforts to document, quantify, understand roles of management practices on water quality. Greg, can you walk us through maybe what we're looking at a little bit here?
What we're trying to do is make the linkage from the field here in London, Ohio, to the stream that's behind us here that we'll show later, down and out and through, which in this case is the Mississippi River or Ohio River to Mississippi River, and then ultimately the Gulf of Mexico. When we talk about most of our sites, they are located up in the western Lake Erie Basin, and in that basin, what we're trying to do is quantify what water quality looks like coming from the edge of field, how that multiplies or subtracts as it goes downstream and ends up in the western Lake Erie Basin.
Okay, that's great. So maybe we can even back up a second and just maybe you tell us a little bit about, you might have, or students might have heard, or people might have heard about water quality in Lake Erie. Can you explain the situation? What's the story with water quality, and why is Lake Erie such a big deal?
Yeah, there was noticed an incidence of an increased amount of really cyanobacteria versus algae. Cyanobacteria are a blue-green algae that certain species fix their own nitrogen, other species don't. But the incidence of those started to increase back in the early 2000s, becoming coverage over the western part of the Lake Erie Basin, really that shallow area that's from the island area back towards the shore in Toledo and Michigan shorelines. And so that issue started to occur. There was a phosphorus task force that was named at that point to try and explore why we were seeing the increase in cyanobacteria after not seeing them in the mid-90s. And that allowed us, through the phosphorus task force, to start identifying where the phosphorus was coming from, and it was discovered that a lot of it had been cleaned up from the point sources, the wastewater treatment plants and other types of pipes that go into a stream and are measured. And what we discovered, that most of the phosphorus coming in was from non-point sources. It would be the land uses out in the watershed. Obviously up in that basin, 78% of the land is under some kind of agricultural production, so that puts the focus back on agriculture. Not that non-point source equals agriculture, but it is certainly an important component.
So that's an important point that we talk about with water quality. It's this idea of point source versus non-point source. And non-point source is just generically something that's not coming from a very specific place. Is that right? Or how would you define that?
I would define point source as it is enough volume of water that's leaving a site that it is regulated.
Okay.
I mean, we can still have point sources that are unregulated just because the volumes aren't great enough to trigger EPA regulations. So point sources are those large contributors to a watershed, wastewater treatment plants, industrial plants. You have things like Campbell Soup, and you have a steel plant up in that area. They all both have regulations on them in relationship to point source releases. So it's anything that comes out of a pipe that's at the watershed or going into a stream or ditch or whatever, and is measured or can be measured easily.
Okay, so farmland, most farmland acres would be considered non-point source in that regard.
Absolutely, and it falls under really the regulations of the waters of the United States and so forth as a non-point source, just because while we use subsurface drainage, that doesn't get counted as a point source or a pipe that's going into a stream that can be measured.
Is it just Lake Erie, or are there other bodies of water in the state that are affected with water quality issues?
Well, actually, water quality issues from nutrients is a worldwide problem. We can look in Ohio and see different regions, even in our own state, that have issues. You can look at Grand Lake St. Mary's, which is another water body that is in the news quite frequently. That has cyanobacteria, harmful algal blooms, as we're discussing on Western Lake Erie Basin. 2015, we had conditions within the Ohio River that we had a 600-mile long harmful algal bloom within that, so they can pop up anywhere along the lines. Then you start to go out of state of Ohio into Florida, and you start hearing about red tides and other types of issues. So really, it's not unique to Ohio, but certainly the Western Lake Erie Basin has a different characteristic to it that really makes it something central for us.
Okay, and so a lot of talk about water quality in Western Lake Erie Basin. Why is it concentrated there and not maybe the Scioto River or the Ohio River?
Well, what you find in the Western Basin is we've got a portion of Lake Erie that's only about, on average, 24 feet deep. So we have a shallow basin that goes up to the islands that folks might be familiar with, that kind of rim that Western Basin area. What we see with cyanobacteria up there is just the presence of them. You know, the water turns green from the presence of the cyanobacteria in the water in volume. That causes an issue just from an aesthetic standpoint, from recreational use. It does wash up onto beaches, so can be an issue from an aesthetic standpoint there. Also, we have several communities up in that area that utilize Lake Erie as their water source. And with cyanobacteria, we not only have the bacterial presence, but probably most importantly, those cyanobacteria will produce a toxin. It's actually a toxin that's stronger than dioxin from a natural toxin standpoint, and it gets into can be produced by the cyanobacteria under certain conditions, and that causes an issue then with the intakes of the communities and the drinking water, and either they have to increase treatment, or as we saw in 2014 with Toledo, actually enough got through that there was a system-wide warning put in do not drink, and they were unable to use their water supply for about 72 hours.
Okay. So it's a human health issue, then. That's why a lot of the attention is amplified in the Western Lake Erie Basin.
A strong liver toxin.
Yeah. Okay, gotcha. Great. Okay, so I want to talk a little bit about this facility, what we're standing here, why it's unique, a collaboration between Ohio State and USDA. And can you explain to us what we're seeing in the background here?
Yeah, what we've got back here is we've got a watershed. If you can look past the corn, we've got about, I think this side is about 14 acres that is both surface drain to this location, and then we also have tile drain that also go to this location. This is the surface sampler right here. Basically what we have is some wing walls out here that the water coming off the surface is directed through this point. So all of the water coming off that 13 acres comes through right here. We're able to measure it coming in right here at this point, and then we're taking a sample when we have a certain volume of water coming through.
So we get a rainstorm, enough of it when it's actually causing a runoff event, and then it's collecting right here, and it's moving through here, and this is a sampler. It's actually pulling a sample, right?
Yeah, on a sampler, there's a set of bottles in there, or a sampler that has a set of bottles in it. It pulls on a time interval based off of it. This is one of several sites where we don't get a whole lot of surface water. Even though we have topography here, this is a site that has pretty well drained soil. So most of the water actually comes out through the tile system.
So can we actually look inside one of these and see what we've got?
Yeah, let's look at the tile site over here. Yeah, what we have with these, both the subsurface and the surface water, we have a sampler that is able to automatically sample as rainfall events occur. So this site does not need to be manned. What we have is really two pieces to this. We've got a bubbler system over here. That bubbler system puts as a pulse of air through the pipe that goes into, in this case, the tile drain over there, and it is able to measure the volume of water by resistance that is going through the pipe. So once it hits a certain flow volume going through, it will kick on the sampler here, and it will start to sample on incremental, I think they're 15-minute increments, and place into the bottle or bottles that are located in here water that's collected. That water then gets taken back to the lab. It's measured for total phosphorus, dissolved phosphorus, nitrates, total nitrogen, suspended solids, and probably a couple of other things that I'm forgetting about, but those are the main things we're concerned about from a nutrient standpoint.
Okay, so this is an insulated box, and it's pulling samples. And how long do these samples stay in here before they're actually analyzed? Are they analyzed in-house, or what happens to them next?
They are collected once a week, particularly during the rainy season, maybe more frequently if we have a lot of heavy rain. It's insulated, as you see, and that insulation means we also have a small heater from an RV in here, so whatever happens over the winter months is not lost. It is captured, and this monitoring goes on 365 days a year at this site. The samples are collected by a crew from USDA, and they take them back to the lab in ag engineering and go through that process of doing all the analysis on it and in that location. Okay,
and it's driven by solar panels up here that keep it warm and keep this machinery moving, right?
Actually, the solar panel provides the electric. There will be a propane, well, there actually is a propane tank on the side that drives the heater, and it's a small RV heater, so it provides enough heat just so it doesn't freeze inside the box with the insulation.
So this one is pulling, we talked about that flume for surface runoff. This one's actually pulling the tile flow, right?
From the tile that is over in the stream, Deer Creek here.
Okay, so we're actually measuring at this site, we're measuring flow that's coming off the surface, and we're also measuring that water that's percolating through that soil into the tile and getting drained into a header and then ultimately into a water body, right? And this is Deer Creek, you said, is that right?
Correct.
Okay.
And remember what we do with tile. Basically what we're trying to do is drain excess water out of the profile. Not drain the profile completely, but get excess water so we maintain air in the soil profile so plants can grow.
Okay. Now, is this set up? This is pretty impressive to see that. Is this the only one on this site? Is there a second site, or how many of these are in the state?
Yeah, actually each site like what we're looking at here has a companion field that is being monitored. Actually, this one is just a little bit to the south, about 2,000 or 1,500 feet or so. And what we do then is we have a second setup that looks exactly like this, monitoring a different area of the field based off the topography and a different tile system. And what we're able to do is once we get through a calibration phase, knowing that the two sides are how the two sides react, they don't have to react equally, but we have to know what the reaction is, then we can start putting treatments. And actually this site, the treatment that we've been using is this north side of the field that we're on right now is a no-till field. The south side is a tillage field. Okay. And we're doing intense tillage and looking at the difference in relationship to that tillage treatment on this site.
So just asking that question, how does tillage influence water quality, influence phosphorus loss from a field, is, you can see, incredibly difficult and complicated to actually get at, right? Because we've got a situation here where we've got very expensive instrumentation, a crew that's got to come here and sample, not just once a year or twice a year, they got to sample essentially year-round when there's water moving. And then we've got to do two different fields that are located relatively close, similar, soil characteristics and topographical, et cetera, and then we've got to actually take a baseline for a year or two or three, and then do a management implementation where we actually hold one tillage versus no-till, and then collect that for several years. Then after all that, we get to answer that question for one site in Ohio. Is that right?
That's correct.
Yeah.
And what we do have is a total of 20 sites. So there are 40 fields with this same type of monitoring equipment on them. We have a number of different things that are being measured at those different sites. But as you said, it's not a heavily replicated trial. It's not what we're used to from some of the ag statistics, and there is a whole statistics type of setup and process that goes along with these paired sites, which is what we're talking about here from a water quality monitoring standpoint, a paired site design.
Okay, so we're down the bank from where we just were. This is actually the tile line that's dumping into Deer Creek, okay? And you can see this would look normal on an ag landscape. This is what's a little different, and this is actually the sampler that's going to be pooling water from that tile line. Is that right, Greg?
Yes, that's what connects to the other pieces that we were just looking at. Reality, there's a third piece and an important piece, because this is a weir that holds the water back by this bubbler and the resistance. We're able to measure due to the notch in there. We know what volume of water is coming over that. It backs up the water so that the bubbler can do its work to measure flow coming through the tile line.
Okay, so that's a really important question, because it's one thing just to measure concentration of nutrient in the water, but we actually need to know how much water is moving through that system, how much water is moving through the tile versus through surface runoff, because if we just have concentration, we're not going to know how much total, like how many pounds of phosphorus are getting lost. Is that right?
Yeah, exactly. I mean, you got to have both factors to come up with that value of loading coming off of the site. And when we look at the Ohio EPA mass balance study for Western Lake Erie Basin, what we see is there's about, from non-point sources, 1.2 pounds per acre that come off. In the 20 sites that we mentioned, our average loss is about 0.75 pounds per acre of loss of phosphorus. So we can quantify what's coming from agricultural fields, at least those 20, try and extrapolate that and understand better what agricultural practice impacts there are.
Okay, so let's talk about that for just a teeny more second. We're talking about, you said 1.25 pounds to 0.75 pounds per acre of actual phosphorus loss.
Yeah, and I'll back up and just clarify. Ohio EPA mass balance study says by taking all the acres up in that basin divided by the non-point source contribution, says that there's 1.2 pounds per acre coming off.
Okay.
What we're measuring at these 20 sites is 0.75 pounds of phosphorus coming off. Okay. So it starts to give you an idea that there's some other things that probably contribute up in that basin. There's 22% of the land that's not in agriculture. There's some cities, towns, yards, areas that are under building sites that have erosion. There are 14,000 miles of stream that have erosion along those banks. So there's contributors that go beyond our agricultural practices, and we're really not doing a very good job of trying to sort those out at this point, so we can target better where we need to put things in place.
Okay, so for the 20 sites that we've been working at, about 0.75 pounds or so, that's on an annual basis, right?
Annual average basis.
And then what would be like a typical application rate that we would be applying, or what would be how much is that a percentage in terms of what loss would be on average? Like in a rough ballpark, would you estimate?
Well, and we're talking elemental phosphorus in our first discussion here. When we go to P2O5, fertilizer equivalent value, what we're doing is putting down around 60 pounds of phosphorus for a 180 bushel corn crop. Okay. That would be crop removal type of rate.
Okay. And so if we back that up, that might be about 30 pounds or so, 25 pounds of elemental P. So we're really at less than 1/25 of what's getting applied is what's getting lost. And of course, what's coming out is not just that fertilizer from what's being applied that year. It's a lot of residual or legacy phosphorus as well, right?
Yeah, there's total phosphorus in the soil is probably 600 to 1,000 pounds per acre, and it's just driving that small amount that we see as far as soluble in the soil solution that feeds plants, or in this case, leaches offsite.
Gotcha. So for phosphorus in particular, we can have large losses of, say, nitrogen on how much N we apply versus how much is actually lost through leaching or denitrification, volatilization. For phosphorus, on a mass balance perspective, it's pretty small percentage of the total fraction that's applied as fertilizer.
Yeah, and when we start talking about nitrogen, we get into several magnitudes greater as far as the amount of loss. When we go to the mass balance study, it's around 25 pounds per acre of nitrogen loss. Okay. And actually, I think that's nitrate loss in relationship to per acre. And I don't have an average number for the field sites, but I know those field sites range from anywhere around 15 to 20 pounds per acre up to we've seen 120 pounds per acre. Okay, well. And that gets into rate discussion in relationship to nitrogen, because we know nitrogen, while organic matter holds a small fraction, it's not anywhere near what we need for producing corn, for example. So we do need to think about our rate in particular in relationship to nitrogen, nitrate loss, what's left over at the end of the season, and trying to minimize that. So typically that nitrogen comes out after the season and through that early spring period.
Great. Can you just tell us a little bit more about what Ohio State, what farmers are doing to help water quality issues in the state?
Well, what Ohio State's been doing, particularly from extension standpoint, is outreach. We've been developing some materials that farmers can use. We've spent a lot of time on fertilizer certification, understanding rates, understanding recommendations, understanding soil testing, and that's really a critical thing. That soil testing piece that you're learning about is critical in relationship to understanding not only crop response, but I think it does very definitely tie into this environmental impact. Those are a couple things that we're doing from an educational standpoint. A second piece that we've developed is an Ag BMP handbook, which talks about some different management practices that we can put in place. Kind of goes through the pros and cons and cost and some of those things that farmers would want in relationship to implementation on their field operations. So what farmers have been doing is, I think, as you look at fertilizer sales in the state of Ohio, the phosphorus side of sales have dropped and been dropping. So we're actually at a crop removal type of rate where they're actually removing more nutrients from the soil than what they're applying. So that's good. That should lower the soil test values, which is one of the critical things that we look at. And soil testing goes along with that very well. And, you know, we see and believe that around 85% of the acres in Northwest Ohio are being soil tested. We also have NRCS doing some surveys. They're going to release one that I've been told that may even show that that's improved since 2012. So soil testing is critical, an important part. A lot of investment has gone into manure management, doing that better, taking advantage of the nutrients from a crop production standpoint, trying to reduce the excess in the field. The other thing that we've been talking about a lot is subsurface placement, getting that nutrient off of the surface, whether it be, you know, when we have planned tillage, going in and applying fertilizer before that, or banding fertilizer with high-speed tools. All those have pros and cons and costs that have to be considered in trying to make things work.
Okay. So my original question was about what are Ohio State, what farmers are doing. It's really important to understand that this is not just an Ohio State initiative. Of course, lots of moving parts here, lots of places. People like, you know, great scientists at USDA. We've got people at Farm Bureau, in the checkoff programs, corn and wheat, marketing programs, Ohio Soybean Council, Nature Conservancy, Environmental Defense Fund. There's a lot of kind of folks from the business side, from the ag side, from the environmental side, all kind of coming together working on these issues. It's a really important topic, right?
Yeah, important topic, and we ought to mention some of our other universities. Heidelberg University does all the river monitoring. We see University of Cincinnati doing things in relationship to toxins in drinking water and removal. There's a whole variety of impacts that are going on at different universities scattered throughout the state, and it is a topic that we kind of have all hands on deck. And with that, the governor just passing the the H2O Ohio, or the legislator with the governor passing that type of package, which is a pretty significant investment in what's going to be practices, and coming from several different angles trying to address this problem, not only in Lake Erie, but also statewide, and some of the issues we have in trying to have water quality and quantity.
Yeah, so there's a lot of actors in this space, a lot of people trying to work together as proactively as they can for kind of fixing some of these issues, right? Very complex environmental issues and a lot of different interests at stake. It's what makes it interesting and challenging and sometimes maddening, of course. But,
sometimes I'm beating my head against the wall. Other days I feel like we had a good meeting and accomplished something and we're headed in the right direction.
Okay, great. And just to wrap up, how long have you been working on water quality issues in the state, Greg?
Well, really, 2011 is where my start point became, and that's often what I like to, and it doesn't hit the audience very well, particularly the non-farm audience, but in reality, we haven't been working on this issues since 1972. We've been working on this since about 2005, 2006. And so for us to think that we're going to solve it overnight, it didn't happen overnight. We're not going to solve it overnight. There are no silver bullets that we're finding in all of our research. There's just a whole variety of knobs and buttons that we need to push and twist to make things work.
And it takes buy-in from like all sources, right? It takes buy-in from farmers, it takes buy-in from policymakers, from the ag industry. Education is a critical piece to all this. So it's been a fun road since I've been here, and appreciate you sharing some of your insights, some of your perspective with us.
So some of your students will be working on this for a long time after I retire.